Good morning. I'm Pradeep Kumar, Assistant Professor, Department of Computer Science and Engineering from AJ Institute of Engineering and Technology, Mangaluru. So we are discussing about operating system, for which we have took the topic of from the module 5. So under module 5, the entire module 5 is divided into two parts. First part, secondary storage structure, and the second part is protection. So we already covered the first part, secondary storage structures. So today we'll see some of the topics from second part, that is protection. So we are going to cover these many topics: goals of protection, principles of protection, protection rings, domain of protection. So today we'll cover these four major topics out of this. So after completing with the domain, so we'll have access matrix, revocation of access rights, role-based access control, and mandatory access control, then capability-based systems. Continuing further, so the major objective of this is, so we'll discuss the goals and principles of protection in a modern computer system. So we are going to discuss about protection domains. So how we can combine with the access matrix, which can be used by different resources. Then we may examine capability and some of the language-based protection mechanisms, and using the protection mechanisms, how we can mitigate system attacks. So these are the few objectives. So we'll start with the topic goals of protection. So in general, why we need protection? When we say operating system, so what are the importance of protection coming to the operating system? So the major part is, when we say computer, it consists of number of objects, number of hardware, number of softwares as well together, right? So to deal with this, to protect from unauthorized activity, to protect from unwanted entry, to protect from privileged data, we need a protection. So now each object in computer, it has its own unique name and number. So each object has a unique name and it can be accessed through a well-defined set of operations. We have seen different objects in the last class, the previous class as well. For example, if you want to deal with data that is to be stored in a disk, so it will have a name, it will have a location, it will have a identity. So via disk control, we can access those things. So how we can protect that particular data? So to protect the data, whichever already stored in a disk, you're supposed to set up some guidelines. So that is via using set of operations. The major problem or major hurdle is to ensure that each object is accessed correctly and only by those processes that are allowed to do so. Saying that, so whenever we have a data or an object in our disk, we should guarantee in such a way that, so that particular data can be accessed only for a genuine person or a genuine process only, so that only authenticated process can be accessed that particular data. So we can give an example. For example, we are very much familiar with the VLC media player. So using VLC media player, we will make number of playlists. Each playlist may be dedicated to one of the, say, singer, or maybe the album, or any manner, no issues. So now consider the situation. You have 10 songs in a single playlist. In second playlist, you have another 10 songs, 10 set of songs. So while playing the fifth song from first playlist, automatically, if your VLC media player directly gone with the playing with the second playlist automatically, without knowing or without informing you, for example, then that is a protection issue or protection problem. On the other hand, if you can give another example, in general example, with respect to classroom situation, The student can access only few materials that is shared by them. If a particular student is trying to access the material which is given to some of other students or maybe for the other class, that is where protection will come to picture. So that will be the problem. So we as operating system administrator, we supposed to provide systematic accessibility to avoid these kind of protection problems, saying that only the data should be accessed by the genuine persons, genuine processes only. That is the major goal. Then, so we have some principles, the principles of protection. So the major thing over here, principle is, it should be guiding everyone, saying that we supposed to set levels of privileges. We'll use the term principle of least privilege. So with respect to privileges, programs, users, and systems will have their own privilege levels. Privilege in the sense, in general, if we consider with respect to Unix system environment, we have something called RWX setup: read, write, and execute. So some programs will be given only with the read privilege, read accessibility, reading priority. Some users may be given with write and execute and read everything. Some systems may have only write privileges. That is how the principle works. So the first thing is the decision should be made clearly in such a way that which are the programs should have read facility, which are the programs should have write facility, which are the programs should have both read, write, and execute facilities. Similarly, some of the users will have a guest role. Some of the users will have administrative role. Some of the users will have programmer role. So with respect to these things, how we can set up the privilege for the data which is already available in the disk, or the particular person, particular user, what he can do with the machine. That is how the privilege works. So based on these different criteria, we are supposed to identify the privileges. So after identifying, we are supposed to set the proper permissions. That is what we discussed. Read, write, and execute. Properly set permissions which can limit the damage of entity has a bug or gets abused. So right now, so if we can discuss according to the example of whatever we can hear or we can read from the newspaper or we can listen to the TV. So there are so many bugs. For example, ransomware. If you recall, the last year in 2019, ransomware as a bug, it interfered into Windows platform. Those who worked with the Windows 95 and Windows 98 machines, they kept the one who sent or the thieves, they kept that entire machine into under their control, and they are asking for some of the, say for some of the what they call Bitcoin. Yes, yeah, Bitcoin thing. And that is one type of bug. Another type of bug is the other persons or intruder or third party may enter into your account, and the intruder may post you something on it through a mail or a watch or a mailbox, a message box, whatever it may be. So that is how, if you do not set up the permission properly. So if you have those kind of setups, so we can limit the damage, we can reduce the damage. So only one user should give a administrator authority. So other persons should follow administrator's orders. So administrator himself will set some rules and regulations. That rules and regulations should be followed by others. So the rules may have been changed to person. That is how the permission. So now coming to this permissions, it can be static or it can be dynamic. What is static? Static is during the life of system or during life of process. It should be constant. For example, if it is an administrator role with the machine, so his role is he can do anything on that particular machine. He can have read, he can have write permission, he can have execute. Read, write, and execute, all the three permissions. No need to change. So that is a static level. So once you are given with the username and password or other credentials, you are the owner of that particular machine. You can do anything. That is static. The dynamic is depends on the usage, and depends on the access. Each and every time your permission levels or privilege levels has been changed. That is changed by process as needed. So this particular point, it will highlight that one. That is dynamic. It is changed by the process as needed. So we'll discuss with an example. So we can go with the domain switching and privilege escalations. For example, based on a particular application, few users may given with only guest role. So they can access whatever they can see on that particular machine, only access permission. Or on the other hand, only read permission. Some of them may have write permission as well. So this is changed with respect to your login. For example, in the morning at 9 o'clock, you may read all whatever the data you have. In the afternoon, you may get a write permission as well. You may update whatever the data you wanted to update. That is how permission change or domain switch works. On the other hand, if a normal user or a say guest user, those who are having only read permission, if they are trying to access the particular data with respect to write permission, then we can say it is a privilege escalation. We can easily, the particular administrator can raise the issue saying that the particular user is misbehaving, or on the other hand, the particular user taking an advantage of the privileged permission, so that the privilege is escalated. So that is dynamic. So dynamic in the sense each and every time permissions or privileges can be changed. If it is static, it is constant throughout the life of system or throughout the particular application executions. Then we have something called compartmentalization. So compartmentalization is nothing but it is related with the access about the data or access to the data. So over here, compartmentalization is nothing but individual system component can be given a specific permission and access restriction. For example, a particular application, if you consider say VLC media player, using VLC media player, you can play MP3 songs and MP4 videos. So we'll restrict only with those two formats. That is compartmentalization. You are supposed to restrict your application in such a way that it can access only a particular type of file. That is compartmentalization. You are restricting to a specific type of file, specific type of data. So that is what the last point says: specific permissions and access restrictions. So, okay, clear? So we'll go further. Continuing with the same principles of protection, we have something called grain aspect. So here we have again rough grain and fine grain. Coming to the rough grain part, with respect to rough grain, it is very easy, very simple. But one thing is least privilege. So only read permission. For example, say with respect to if you read online newspapers, it is very easy to read. It is very simple. It will be opened as in the form of either PDF or in the form of chunks, say block of news. It is very easy. Only thing is you have only read permission, right? That is how rough grain works. On the other hand, if you consider Unix processes, traditional Unix processes, so we have those abilities which is associated with the user or of root. So each user will be given with one particular privilege. So that particular privilege is easier to manage. For example, 100, if you take an example of VTU results, we all are the users of that VTU result page. So even as a normal VTU users, so it is very easy to find out the result if you know the USN. So that is how, by providing a USN as a data, we are fetching the result from the server, VTU server, right? So that is easy to manage. Whoever knows your USN, they can access your result. That's all. Nothing else can be done. They can't access your data, so they can't utilize your data number. They can't change. Nobody can change. That is how rough grain works. So it is easier, simpler. And coming to the second part, that is fine grained, which is a little bit more complex. and have more overhead but more protective. So here complexity is concerned with the administrator should be aware in such a way that who are given with the all or read, write and execute all permissions. He is supposed to watch and overhead. So maybe a little bit fear if something happens with the data, what should be done? Or overhead to the database, overhead with the processor. So all the permissions, all the privileges are given to the some of the persons. If you consider as an example, we have something called file ACL list and RBAC. So file ACL, so for example, a list of files with all the accessible permissions. So we'll see that particular part later. The next point says domain can be user, process and procedure. So whenever we say a particular domain, a particular area, it can be an user, it can be a process, it can be a procedure, anything. One more principal part is audit trail. So nothing but we'll have a log page kind of thing. So all the entries can be made into that. So it's nothing but it will record all protection oriented activities. So why we need these protection oriented activities? That is important to understand what happened, why it is happened, when it is happened, and what will be the reasons. So everything is recorded in that audit trail. And there is no single principle so that you can avoid all the security related issues. But there is a need of defense in depth. So you should be prepared in depth. You should have an in-depth knowledge if somebody went wrong with the different privileges, read, write and execute. So these are the major principles of protection. So to cover with those things, we have something called protection rings. So protection rings are nothing but the set of components which are ordered by amount of privilege and protected from each other. Saying that it is a block in the form of ring. So that particular ring, each ring will have set of users. So only whoever comes into that particular ring or set, so they have only protected data that can be read and read, write or execute. So we'll have a group, we'll have number of groups. Each number of groups, each group can access, can deal with only the group of data, not with other ring, not with the other group. So that is what we meant. So each components will be ordered by amount of privilege and protected from each other. So we'll make subgroups. So each subgroup can have their own data themselves. So for example, we can give an example of kernel. So kernel is in one ring and user applications in another, that is in the top. So the user applications can utilize the kernel setup. So to do this, to do with this particular separation, we need hardware support. So to deal with the hardware support, so we need gates to transfer between levels, system calls to the Intel instructions, traps, interrupts, all those. Or we can have hypervisors introduced the need for at another ring. So we can see in some of the examples by some of the manufacturers. So ARM V7 processors, ARM processors. So they added TrustZone TZ, TrustZone ring to protect crypto functions with access via new secure monitor call instruction. So they built separate component, say TrustZone. So nothing but a protection ring. So using TZ ring, they're trying to protect cryptographic functions with access via new secure monitor call instruction. So whenever they wanted to deal with the component or data which is available within TZ ring, they're supposed to make a secure monitor call via instructions. And protecting NFC secure element and crypto keys from your the kernel. So these are the features from ARM V7 processor. This is about protection ring. So here you can see an example. Consider DI and DJ. only two domain rings. So DI and DJ are the two domain rings. The domain is nothing but it may be a group, it may be a set of procedure, or it may be a set of processes. So now with respect to protection ring, or in general we may call it as multics, consider over here ring 0 pointed in the center, ring 1, the outer one, outer to ring 0, and so on. So now what we are trying to say is the innermost ring 0 will have highest protection because it is a little group covered with outermost or so many rings. So this particular ring 0, whatever the data we can have it over here, it will have a secure zone, right? So that is how the protection ring works. So here is an example with the Android use of TrustZone. We all are made use of making use of Android mobile phones, say smartphones. Even Android mobile phone is having this particular feature. So first, say for example, you wanted to uh, you wanted to have different applications in your mobile phone. You wanted to download VLC media player. You wanted to have some other music system in your mobile phone, or you wanted to make use of map, or you wanted to make use of some other things in your mobile phone. So now, with respect to that, is concerned with every application may not be given by the Google itself. Say consider Android by the Google. Not even not all the applications are provided by the Google itself. There are number of or numerous companies or developers who will develop the application and put into the Play Store. So whoever wanted to have a particular application, they will have to download it. So now, with respect to that, if you consider number of applications is supplied by either third party or Android or your vendor, with respect to third party developed application, you can develop your own application and you can have it in your Android mobile. And second part is the developed by Android itself, I mean Google itself, or by the vendor. For example, this vendor can relate with, you can buy a Samsung mobile phone, you can buy Oppo, you can buy Micromax, you can buy MI, Xiaomi, or anything. So these are all the vendors, the vendor specific applications. So now we wanted to have all these different manufacturers application in our mobile. So now how the mobile will trust it? Trust. That's why we use the term trust zone or TZ ring. So first, application in need of cryptographic services uses Android frameworks. So how it is installed in our Android. So that is what this particular diagram is supposed to explain. So first you will download. So we are explaining in such a way that we are familiarizing with the in such a way that you already downloaded the application. So now the application is downloaded. It is ready in your download folder. So you are going to open it for installation. So what happens in the backend is application in need of cryptographic services uses Android framework. So it will request you to access your framework, whether you wanted to install. If you wanted to install, you're supposed to enable. There is a gatekeeper, nothing but developer tools. There is a option in your mobile. If you go and search in your settings, you can find out that one. So that is nothing but you are providing access for that particular application to deal with Android framework. So what that framework will do, framework use vendor supplied hardware abstraction layer, HAL, hardware abstraction layer, to communicate with the daemon. So what it will do, it will trace out the hardware abstraction layer and it will inform the daemon. Daemon is nothing but with respect to kernel layer is supposed to send the system call. So once it is HAL is identified, it will get the privileged user mode access. Otherwise, it may request you to give an access so that that particular application driver can be installed in kernel. So once it gets the user mode, privileged user mode, then kernel mode is allowed to access TrustZone and vendor driver makes a request to install. That is how it works. So once it is installed, you can say that particular application in trusted zone. That is how this particular ring works, TZ TrustZone ring works. So that is enough for time being. We'll continue this particular ARM CPU architecture later on. There is another example for TrustZone. You will see a little bit later.